Before we begin building a lab environment, let's take a look at what a virtual machine is and why we would want to use one. A virtual machine is a software-defined computer that runs inside of another computer. A physical computer is defined by the hardware we place inside of it. How many CPUs, how much memory, and any other devices that are installed on that physical system. A virtual machine, in contrast, is encapsulated in a set of files. This allows for us to rapidly modify the configuration of the virtual machine without having to make physical changes. In addition, because the virtual machine consists of a set of files, anything that we can do with the file, we can do with a virtual machine, including making a backup, copying or cloning it, and sending it across the country or across the world. VMs can have largely the same hardware as physical computer, including network interface card, hardware devices, USB devices, and SCSI devices. Virtual machine uses the same operating system and application as a physical computer from the point of view of the operating system. It can tell whether it's running in a virtual machine or on physical hardware. So why would we want to use a virtual machine? A common reason for using a virtual machine is server consolidation. A physical computer is typically using about 5 to 15% of its CPU. By running multiple virtual machines inside of the same physical host, we can increase the CPU utilization up to closer to 60 to 80% and get better utilization of the other resources as well. Another reason for using a virtual machine is hardware independence. Because a virtual machine abstracts the underlying physical hardware, the same virtual machine can be run on multiple hardware types without having to make any changes inside of the virtual machine. Because the virtual machines are encapsulated as a set of files, they provide for better mobility and duplication. Virtual machines also help to reduce downtime because we can move a live running virtual machine from one host to another host. This means that hardware maintenance operations no longer require machine downtime. Finally, virtual machines allow for automation for development and production environment. The platform that a virtual machine runs on top of is called the hypervisor. The hypervisor is the core of the vSphere environment. It's responsible for scheduling the CPU. All of the virtual machines running on the host directly on the CPU. But the hypervisor is scheduling to ensure that each virtual machine gets the CPU that it's entitled to. The hypervisor is also responsible for sharing the physical memory among all of the running virtual machines. Other types of hardware are emulated by the hypervisor, including SCSI controllers, network interface card, and USB controllers. There are two types of hypervisor that are available: a bare metal hypervisor and a hosted hypervisor. A bare metal hypervisor has less overhead and better performance because it's running directly on the top of the physical hardware. Examples of a bare metal hypervisor include ESXi and Citrix Zen 7. A hosted hypervisor, while it has less performance because it's running on top of an operating system, and does provide for more flexibility and easier management. Examples of hosted hypervisor include VMware Workstation and VMware Fusion. Most production environments run on top of a bare metal hypervisor such as ESXi, while many lab environments run on top of a hosted hypervisor such as VMware Workstation. In this course, I'll be running ESXi on the VMware Workstation as a bare metal. On top of that, I will install a vCenter server for Hypervisor's control center. And finally, I'll install a virtual machine manually on ESXi and so on and so forth.